Electricity is powering your phone, your fan, your Wi-Fi, and even the device you're watching this video on right now. But have you ever stopped and wondered, what actually is electricity? How does invisible energy travel through wires? Why do LEDs glow? Why do devices heat up? And what really happens inside a circuit? In this video, you'll understand electricity completely from scratch using the simplest explanations possible. And once you understand this, electronics will suddenly start making sense forever. Electricity is simply the movement of tiny charged particles called electrons. These electrons already exist inside wires and metals around us, but normally, they move randomly. When we connect a power source like a battery, the electrons start moving in one direction. That movement of electrons is what we call electric current. Now the question is, what pushes those electrons? The answer is voltage. And voltage comes from a power source like a battery. Think of a battery like a water pump. It creates pressure that pushes electrons through wires. Without voltage, electrons won't move. And without movement, electronics simply cannot work. The easiest way to understand electricity is by comparing it to water flow. Voltage is like water pressure. Current is like the amount of water flowing. And resistance is like a narrow pipe slowing the flow. This single analogy helps beginners understand most electronics concepts much faster. Current means how many electrons are flowing through a wire. More electron flow means more current. For example, a small LED needs very little current, but a motor or heater requires much higher current. Too much current can damage components. That's why understanding current is extremely important in electronics. Now imagine if too many electrons flow too quickly. Components can burn. That's where resistance becomes important. A resistor slows down current flow and protects components. Without resistors, many electronic circuits would fail instantly. Have you noticed chargers and electronics becoming warm? That happens because electrical energy is partially converted into heat. Whenever current flows through resistance, heat is generated. This effect is used intentionally in heaters, irons, toasters, and industrial systems. Electricity only flows when the circuit is complete. This is called a closed circuit. If the path is broken, electricity stops flowing. That is called an open circuit. This simple concept is exactly how switches work in real life. There are two major types of electricity: DC or direct current, where electrons flow in one direction, and AC or alternating current, where electrons continuously change direction. Batteries provide DC power, but our homes mainly use AC power. Electricity is not just inside wires. It powers almost everything around us. Phones, fans, computers, cars, robots, drones, medical devices, factories, and even satellites depend on electricity. Electricity is useful, but it can also be dangerous if handled incorrectly. Low-voltage electronics like Arduino are generally safe for beginners. But household AC electricity should always be handled carefully. Understanding safety is one of the most important parts of becoming an engineer. Most beginners struggle with electronics because nobody explains the fundamentals properly. But once you understand voltage, current, resistance, and circuits, everything suddenly starts becoming logical. This is the exact foundation behind all modern electronic systems. Now you finally understand what electricity actually is and how it flows through circuits. And this is only the beginning. In the next video, we'll learn how breadboards actually work and how engineers build circuits without soldering. That's where real electronics prototyping begins. Subscribe now and continue your electronics mastery journey from scratch.